This student book is the 8th one of a set of student books which altogether provides the complete set of information to master SDMX. It focuses on the description of the SDMX NSI reference service infrastructure developed by Eurostat. The modules that constitute the infrastructure are explained in a step-by-step approach. Together with Student Book 7, it describes the SDMX architecture using the pull method for data sharing. This session describes solutions on how to implement the pull method using SDMX. It looks at the context and workflow of the SDMX NSI reference service infrastructure, database schemes and database architectures in the context of the pull method, and provides a detailed step-by-step description of each of the modules. The modules presented use an open source architecture developed by Eurostat. This infrastructure accesses the dissemination environment of a data provider, retrieves and converts the local data to SDMX format, and provides web services to pull the SDMX compatible data by a data collector. In this session, the following building blocks will be presented. Web service provider, the web service interface which receives an SDMX query message as input and provides an SDMX data file as response. Query parser, the module that parses the SDMX query message into an internal SDMX data model. Data retriever ensures access to the dissemination database and gets the data related to the SDMX query message. An SDMX data generator transforms data stored in the internal SDMX data model into an SDMX data file. Not shown as a building block is the SDMX model library, since it is a class representation of the SDMX information model and used for storing and handling SDMX messages within the building blocks of the SDMX reference service infrastructure. It is a reusable component which simplifies the interfaces for the SDMX reference service infrastructure modules and represents all SDMX related information in Java or .NET objects. The workflow starts from a dissemination database and ends with making SDMX compatible data available by using a web service. The sequence involving the SDMX NSI reference service infrastructure starts with a call to the web service with an SDMX ML query message asking a SDMX ML dataset. This SDMX ML query message is sent to the query parser module, where it will be parsed and converted into a query matching the internal data model. Then, the web service provider calls the data retriever, providing as input the internal query, the parameters of the mapping store database connection. The data retriever returns a data message formatted in the internal SDMX data model. Now, the web service provider calls the data generator. It assembles the input of the internal model data message, the DSD and the SDMX ML data format type as input to an SDMX ML dataset file. Finally, the web service provider returns the SDMX ML dataset to the web service client as a result of the process. As outlined in the introduction, the workflow starts from a dissemination database and ends with making data available by using a web service. The dissemination database is the storage data warehouse or database of the organization's dissemination environment that each organization maintains in order to store data ready for publication or dissemination to potential data consumers. There are different ways how data can be stored in the data provider premises. Data are not stored in any database yet. This means a new SDMX compliant database may be created. If data are already stored in a local database and described using local structural metadata, additional structure information is necessary in order to carry out the mapping between the SDMX information model structure and the local database structure. In the case of an SDMX compliant database, two distinct conceptual areas can be determined within the database structure. Metadata structure tables area, tables containing the structural metadata for every DSD loaded, code lists, concepts, descriptors, key descriptors, etc. And data tables area, tables containing data described by the DSD concepts. The structure of a database not based on the SDMX information model can be described schematically. It is composed of the following conceptual areas: local metadata structure tables area, tables containing local structural metadata; data tables area, tables containing data described by the local concepts; mapping tables area, tables containing the mapping done for all the concepts and values between the SDMX information model structures and the local database structure; and finally, metadata structure tables area, tables containing DSD structural metadata as in the previous case. The production flow of SDMX data files in a SDMX compliant database can be described as follows. When new data are loaded, the associated data structure definition must be stored in the database in the metadata structure table area. Data can be selected from the database using a web service with the required parameters. The database containing these parameters is accessed in order to create the data file. The following part describes the details of the modules that constitute the SDMX NSI reference service infrastructure: the web service provider, the query parser, the data retriever, the SDMX data generator, and the SDMX data model library as a class representation of the SDMX information model. The main objectives of the web service provider are receiving an SDMX query message, controlling the exchange of information between the other modules, and responding with an SDMX data file message related to the input SDMX query. The web service provider, as an API, exposes the underlying data retrieval functionality using a SOAP interface. The input is a SOAP message containing an SDMX ML query. Configuration files are given as parameters. The web service performs XML validation of the received SDMX query and includes a SOAP error handler, which checks for the errors during the process and sends the respective response to the data consumer. The final output is a SOAP message, including either the desired SDMX ML data file message or a SOAP error. The sequence begins with a call to the web service with an SDMX ML query message asking for SDMX compact data using the web service method getCompactData. The client is receiving, as a response to his query, one SDMX ML dataset message in compact format. The query parser is an XML parser API implementation for SDMX ML query messages. The SDMX ML query message is stored in an in-memory SDMX data model, making it available for further processing. The inputs to the SDMX query parser are SDMX ML query messages and SDMX ML schemas. The output is the query represented in the internal SDMX data model. The sequences begin with the web service provider creating a query parser instance using the method query parser with SDMX ML schemas as parameters. An SDMX ML query is sent to the query parser calling the method parse. The query parser has to validate the SDMX query with the SDMX ML query schema and to transform it. The SDMX ML query is stored in the internal model, and its reference is returned to the caller. The output of the query parser is the internal model of the query. The entire operation of the query parser is hidden for the final user. As an example, a short-term statistics SDMX query is presented. This query requires the SSTS_ind_prod data flow of the period between 2006-01 and 2006-03 for the activities N100DA and N100DB having frequency M and adjustment W by data provider Italy IT1. The output of the query parser is a query bean object containing the following information. Column 1 represents the name of classes that are inside the query bean object. Column 2 represents the name of the properties belonging to the classes indicated in column 1. Column 3 represents the value of the properties indicated in column 2. Column 4 represents the parent classes to which the classes indicated in column 1 belong. The data retriever prepares the data according to the SDMX ML query stored in the SDMX data model. This query is translated to an SQL query involving the mapping information from the mapping store. This query retrieves the desired data from the dissemination database, which is returned as data message in the internal SDMX data model. The connection string to the mapping store database is provided to the data retriever as an input parameter. And the SDMX ML query represented in the internal SDMX data model is provided to the data retriever as an input parameter. Access is required to the mapping store database to retrieve the mappings, and to the local dissemination database to retrieve the data. The output of the data retriever is the SDMX ML dataset represented in the internal SDMX data model. The caller initiated the sequence with an instance creation using the method dataRetriever without parameters. The query in the internal model format is passed to the data retriever calling the method retrieveData. The mapping store connection is provided as parameter. The data message is stored in the internal model, and a reference to this data message is passed back to the caller. The function getDSD is used by the caller to get the DSD in the internal model format. Finally, the DSD is stored in the internal model format. The query bean object from the query parser is used now as input for the data retriever. The data retriever processes the query bean object following the mapping rules created to translate the DSD concepts and codes to local database concepts and code. The main output is a data message object containing a data set with data retrieved from the local database and already mapped with the DSD concepts. The content is displayed in the following table. Column 1 represents the name of classes that are inside the dataset object. Column 2 represents the name of the properties belonging to the classes indicated in column 1. Column 3 represents the parameters for the properties. Column 4 represents the values of the properties indicated in column 2. And column 5 represents the parent classes to which the classes indicated in column 1 belong. This module is responsible for creating the final SDMX ML dataset messages. It performs the translation of the data message in the internal data model to a SDMX ML dataset. The input of the SDMX data generator is a data message represented in the internal SDMX data model. Additionally, some metadata are required in order to produce the data set: the data structure definition and the SDMX ML dataset message format, giving the format in which the dataset should be written. The output is an SDMX ML dataset. This sequence describes the generation of a SDMX ML dataset in compact data format. First, the caller initiates a data generator instance using the method compact data writer without parameters. Then, the data message in internal model format is processed, calling the method write. The SDMX ML message format and the internal model DSD are provided as further parameters. The SDMX ML compact dataset message is created and the reference is passed to the caller. The SDMX data model library represents the SDMX information model inside the SDMX reference service infrastructure. It is a reusable component which simplifies the interfaces for the SDMX reference service infrastructure modules and represents all SDMX related information in Java or .NET objects. The SDMX data model serves as structure inside the service infrastructure for information stored in the SDMX queries messages, as well as to produce the SDMX data message and its metadata. The SDMX data model includes readers and writers which contribute in interfacing the modules.